Let's see a medium level problem from LeetCode. It's a divide to integers, but here we are not supposed to using any multiplication, division or mode operator, and without using this operator we need to find the answer. So we have to divide that to integers. And there are some constraints given here. Also you can see the note also. Assume you are dealing with an environment that could only store integers with the 32-bit sign integer range -2, so we need to consider this also. Yeah, so before looking at the solution, we just try to understand how we are going to solve, and then we can come and see this how I have implemented. So we know if you want to divide 10 by 3, then in this case we are not supposed to use this operator, division operator, but we can use left shift operator here. So we are going to use the left shift operator. But before that, yeah, let's try this strategy, understand this strategy, and then we'll use left shift operator. So one thing we need to understand, like here, like if I say 1 and left shift 1, then it will be, the answer will be 2, because if I do one left shift, then it's a divide, it's a multiply by 2, and if I say 2, then multiple of this 2 is a 4, so the answer will be 4. If I say 3, then 2 to the power 3, it's 8, so 8 into 1, so 8, so answer will be 8. So at least we can utilize this property, and let's see how I'm going to utilize this. If I want to divide 10 by 3, then I can multiply 3 by 2, right? So 3 into 2 is 6, and 3 into 2 into 2 is 4, I mean 12. So here, like 2 to the it's like 2 to the power 2 is a 4, and 2 to the power 1 is a 2. So what I check, like first I check this number is less than 10 or not. Yes, 10 is less. So if I multiply by, or it's a multiply by 4, then it is this divisor is less than 10 or not. No, it's not. So we can stop here, and in this case this is multiply by 2, that is left shift by 1. So this one, you know, or this one, or we can left shift to the 1. So left shift to 1. So if I left shift to 1, left shift 1, then it's a 1 into 2, because when I left shift, then 1 is 2 to the power 1, so 2 to the power 1 is 2, so multiply by 2 and we will get the answer 2. And then from 10 minus 6, this 10 and this 6 I will subtract, and we'll get 4. The later again we'll check this 3 into 6 is less than this 4 or not. No, it's not. Then in this case we can left shift 1 by 0, that means 2 to the power 0 is 1. So in this case that will be multiplication will be 1 into 1, so 1, and 2 plus 1 3, that's the answer. So in the similar way we can check this one also. 20 by 3, answer is, expected answer is 6. So I will do the 3 into 2 6, 3 into 2 2 12, 3 into 2 is 24. So this 12 is less than 20, Okay, so we are good here, and this 24 is not less than, so we can stop here. And this time it's the 2 into 2 is the count is 2, so 1 left shift 2. So when I do the 1 left shift 2, that means 2 into 2 4, so that's 1 into 4 is 4. Okay, I will add this 4 in answer, that's 4 is answer, and I will subtract 12 from 20, and we have now dividend is 8. So I can check from this 8, the 6 is smaller, 12 is not, so we can stop here. So if it is stop here, then it's 2 to the power 1, so 1 into 1. 1 is a 1 left shift 1, that is 1 into 2, that's a 2. So we can add the 2 in answer, and that's a 6. So that's what exactly I'm going to do. So let's see our solution based on this strategy. Yeah, so here you can see here there is a few corner case, so I can explain this. So if the divisor is -1, this divisor -1, and the dividend, this dividend is math mean in 32, that is it's also a minus, it's a mean in 32. So mean in 32 is this one, minus 2 to the power 31. So both are minus. So if you divide minus by minus, that turns to the plus. So the max value will get it's a max in 32. So that's what we get, that this values, that's why we are returning that. So that's a corner case. If dividend and divisor, any of these is minus, or dividend or divisor, so this is just checking any of is in minus, then sign will be the minus, we'll get the answer minus if any one of these is minus. So that's the condition we're checking here. Now we got the dividend and divisor, we got the absolute value, we'll add, and then when we get the answer, check the sign. If the sign is minus, then we'll return the minus result, otherwise we can return the result. Now let's see the main logic here. So I'm checking, the dividend is greater than divisor. Okay, first I have to check this dividend greater than divisor, then only we can divide. So if this is the condition, the count 0, and now I'm checking this divisor left shift count plus 1. So count plus 1, count is 0, so it's a 1. So left shift 1, that means divisor multiply by 2, 1 is 2, so divisor multiply by 2, so divisor is 3 and multiply by 2 is 6. So dividend is still greater than 6, so count is 1. And next time we'll check count is 2, so 2 multiply, so 2 is 2 left shift, that means that is 2 to the power 2 is 4. So 4 into divisor 3, 12, and the dividend is not greater than 12, then we can stop, and the count is 1. So that's what exactly I have done here. In this case 3 into 2 6. So the first time this was 6 and the dividend is greater than that was count plus plus, and the next time count, this is 2, and then when left shift 2, that means we multiply by 4, then that's 12, and when it is at 12 will not go inside and come outside. So the count is 1 itself, and then 1, and 1 is actually 2 to the power 1 is 2, so we are multiplying 1 into 2, so T2 is 2, so result will be 2. And then we divide, we subtract from the dividend, we subtract this 6, so divisor and this CNT was 1, so 1, that means multiply by 2, so divisor into 2, 3 into 6, and that 6 we subtract, and there will be remaining 4. So the logic works in this way. So let's set the debug point also, and we see how the value is getting changed here, so for the better understanding. And if you have got the ideas, you can skip from here, otherwise you can stay with me and just see this value. So I set the debugger point here, and then run it. So you can check now our dividend result is 0, signed 1, because the no negative value, and it's 20 and 3. Also we can check for 10, so that will be easy. Let me debug this time. Yeah, it took 10. Okay, so come here, count 0, and this time maybe I can just, in order to show that, I just put that in a one variable, t, and I can put t here. So that's why, in that way we can understand like what's happening here. But this value in a loop, so like first time just I can print there t. Okay, run it again, count 0, and this is a divisor, so divisor is 3 here, and 3, and the count plus 1, so count is 0 and plus 1, so left shift 1, that means it's a multiply by 2, so divisor multiply by 2 is a 6, so t is a 6. So in the next run we'll check, t is 6, so that's the t value. And now dividend is greater than 6, then the count plus plus, come here, and the count plus plus, and count is 1. Next time again we come here, and this time the count is 1, so 1 plus 1, 2, so divisor here into 2, that means 2 to the power 2, 4, so into 4, that is 3 into 4, 12, so 12, so dividend, so this condition false and will not go inside and come here. So now we know the count is 1, so 1 left shift 1, that means it's a multiply by 2, so it's a 2, t2 will be 2, and we'll add that 2 in a result. So you can see t2, and we can add this to result. And now we can subtract divisor left shift count, so count is 1, that means multiply by 2, so divisor is 3 into 2, 6, and 6 we are going to subtract from dividend, so t3 is 6, and now dividend will be 4. Okay, still 4 is greater than, you see dividend 4, and you still see the 4 greater than divisor, so we'll come inside this again, we'll see that t is 6 here, and this condition fails because dividend is 4, so we'll not go inside, and count is still 0, so in this case 2 to the power 0, that's a 1, and 1 into 1, it's a 1, so t2 will be 1, so you can see t2 1, and we can add t2 over there in a result, so result will be here 3, and that's our expected result. And this time we can subtract again this t3, the t3 value is 3, and dividend 4, so that will be 1, dividend 1, and this condition false and come outside, and then we can return the result. Yeah, so That's a logic in Golang. You can check whole logic here. And you can also see Java code. And that's the whole logic. Okay, so that's all for now. Thank you.